Hello, everyone, and welcome back to the application track. Our next talk is from a lead software architect at The Guardian. Please join me in welcoming Phil Wills.
Hi, everyone. So what I'm going to try and do today is give you an understanding of three things: what problems we were trying to solve, the issues that we've encountered, and what's really worked well when we've tried to use Spark. But before I dive into that, I'm just going to give you a bit of a quick background on what The Guardian is and why we'd be interested in the first place. So hopefully, some of you will be aware of The Guardian as a major news organization. So, these days we're based in London but have significant offices in New York, Sydney, and a smaller one on the west coast of America. And as you'd expect for a news organization these days, we have a website, we have mobile apps. As sort of the team which I'm a member of, as well as these, we also have our own custom tools we use to actually produce the content in the first place. And all the kind of pieces which fit these together and help to produce a modern news organization. One thing you may not be aware of as an organization, even if you're vaguely familiar with us, is that we have a very different kind of ownership model from most organizations. We're not owned by an oligarch or by a large conglomerate which needs to keep its shareholders happy. We're owned by something called the Scott Trust, named after this man with the fabulous facial hair here. And that exists purely to safeguard the journalistic freedoms and liberal values of The Guardian, which is brilliant from an editorial perspective, but turns out actually to be really helpful often from a technical perspective as well, as it means that we can really sort of invest for the long term and make sure that we're doing the best possible thing we can for the organization. However, there's a reasonable question you might ask at this point: what problems would The Guardian have that they'd be trying to solve with these kind of solutions? Well, it's not going to be our content. We've been publishing online for the best part of 20 years, and that's built quite a large corpus of content. We've got about 2 million articles or so, but you can quite happily process that on a single machine. So that brings me on to one of our less obvious systems, which is that we have our own custom real-time analytics solution. So this is OFAN, and this is kind of the traffic going on through a day, where in this case, that big yellow spike pointing upwards was when they announced that liquid water had been found on Mars. And sort of this is something which we didn't really set out to do, but has turned out to be a really important system for us, helping to make sure that our journalism gets to the widest possible audience. And these days, it's used by about 2/3 of the companies, that's about 1,000 people or so, are regularly using OFAN to find out what's going on. And we've got about 25 million page views or so a day. For each of those, we actually record multiple events, so that allows us to do things like calculate the median attention time for a piece of content. So how long are people actually spending reading this? Is this just clickbait, which they're coming in and then going off somewhere else as soon as they see the read past the headline? Or is this something they're actually deeply engaging with and getting real value from? So these kind of things mean that actually we're ending up processing about 5,000 events a second in order to support all of these things. So this isn't absolutely fabulously large amounts of data, but it's starting to get to the point where you can't just trivially process it on a single machine either. Now, this system has been really successful, and it's allowed us to do what we want very nicely, and it's all built on top of Elasticsearch, which has worked really well for us and allowed us to grow that system significantly. But there are some limitations there for just using that single model in terms of how we want to interrogate the data. we can't join different types of data together with it, and we do have some people who would like to do some analysis using SQL-type interfaces, and that's just not what Elastic's designed for. So this is the point where we started to look and see, are there other things out there which we could be using effectively to help us get deeper insight into this data and find out more. So, given that we had that, what was it that led us to actually trying to use Spark? Well, it helped that it was coming from Scala. So, as an organization, almost all the server-side work that we do is in Scala. So this was a very natural choice for us to be able to use and move on to it. RDDs felt like a very natural kind of representation of the data, certainly compared to using the sort of native Hadoop MapReduce. So that meant that there was an initial impetus towards it. But in particular, what really drew us towards it was actually the first use case where we started to look at what we could do with the data beyond the basic kind of analytics which we had already. And that was to try and see whether we could do anything interesting with content recommendations. Now, we didn't have people who had large machine learning backgrounds, and actually the person mainly doing this prototype was me, who had essentially zero background in that area. So having something where actually there were algorithms already implemented, and having MLlib there where it had those things ready to use and where we could get up and running and able to actually see whether this was working for us or not quite quickly was really important for us. So, going, and in particular, we spent some time diving down into the alternating least squares implementation in MLlib, and that worked really well for us. And it was great the way that we could dive into it and actually have the references to the papers that it was based on and go and look at them and make sure that these were actually relevant to the kind of problems we were trying to solve. And more broadly, there was the appeal of something which not only had this initial ecosystem, but was gathering so much momentum around it that increasingly, whenever we went to look for something in a broader tool around Spark, if it wasn't there, then almost certainly there was a project just getting started to try and implement it. And the pace with which this has happened is almost overwhelming. I mean, like, some of the things that I'll be talking about today might seem almost antiquated because I was working on them a year ago, and 1.0 to 1.5 is such a big difference with the way that Spark's moving. So once we were on and we were trying to use Spark, what was it that actually got in our way? What were the problems that we faced? Well, for those of you who've actually gone and tried to implement something with Spark, I would be fairly surprised if you've never seen this message. When you're actually trying to run a Spark job, it's quite common that you'll do something, and it's probably your own dumb fault, but then when you get to it, you run your job, and you found out that the executor's lost. I don't know whether it's gone into a deep, dark forest or what, but it's definitely lost. And tracking down where this has actually occurred and why this has occurred and what the problem is, certainly for me, this initially took a long time to work out and try and understand what was going on. Trying to find, a log to tell me what was going on isn't such a simple issue, and often getting to the bottom of the problem took a long time, and I'd go down lots of false alleys of looking at lots of obscure configuration before realizing that, yes, again, I've probably not assigned enough memory to the system for the kind of queries I was trying to do, or in one case, I'd actually assigned so much memory to Spark that I hadn't left enough left for the operating system to actually serialize out the files at the end. So it's, these are really thorny problems, working out how you're actually going to make sure that you do have enough memory and that it's properly assigned for the process. But it can be a real sort of hurdle in terms of working out what it is and getting to the point of getting this right and making sure that you are assigning memory and using it efficiently, because the cycle time for actually getting to the bottom of these problems can be really large, because you can't just go quickly tweak and check what's going on. You know, generally speaking, to actually hit these issues, you've got to be running your application on a large cluster against a large data set before you actually run into them. And so you have to do it again to prove that you've now solved it or not. And as somebody not used to working in this space, it was a bit of a blow to the face to realize quite how long it was going to take me to get through some of these issues once you kind of interacting with them at this pace. Now, this is an apparently very simple bit of code which I could run on the Spark shell, but it may not be completely obvious to everybody what the output's going to be for this. What you might expect this to be is an array of 2, 3, 4. However, when you run this in Spark shell, what you'll actually get is task not serializable. And this is one of those things that it's not like this is a big problem to fix. If instead I make a seemingly trivial change like this, then we do actually get what we expect and can run it. But this still grates on me, because the difference between these two, that should just be a stylistic choice for me. In any other environment where I'm writing Scala, this isn't going to be something which affects me. The compiler's not going to tell me that one of these is incorrect. It's only when I actually come to run it that I'm going to hit this kind of problem. And you know, this is a trivial example, but I found that time and again when I was doing these kind of things, I'd make a change to try and reorganize my code in a way that seemed simpler to me and would accidentally end up making a change which completely broke the system rather than just being something which was allowing me to express what I was trying to do in a way that seemed more natural to my approach. So that I find quite frustrating when working with Spark. Having said that, one of the things that I think is really exciting me at the moment is the idea of data sets. So data frames and the approach that they've taken really do often help to get away from some of these issues by kind of forcing you into a pattern where you're unlikely to hit these kind of issues. But for me personally, I'm very much somebody who really likes my static types, so I have missed them when I've tried to implement some of these kind of things with data frames. So the idea of data sets where you've got that higher level of abstraction, but you've still got the static types is something that I'm really looking forward to seeing and trying. Now, I think with a lot of the talks we've sort of heard or will hear, they're based on people who have teams of like Goldman Sachs with their like 9,000 engineers or whatever it is. And in a lot of those situations, they've got teams of people working to maintain their clusters, keep them up, keep them healthy, provide lots of tooling on top of it for people to do it. That's not the situation we have. We operate very much on the model of you build it, you run it, which is great because it means we can do things like try out exciting new technologies like Spark without having to go through a lot of process to do so. However, it does also mean that we actually have to run it. And you know, there's only a few of us having to deal with these systems. And we also run almost exclusively in the cloud and in particular on Amazon Web Services. Now, that's generally works very well for us, but when we came to start using Spark, at that point, the only way that I could really see to do that sensibly was to use the Spark EC2 scripts. And they mostly worked, but they often, when a new version came out, it took a bit of time for them to actually get to the point where they were working again. And they never filled me with enormous amounts of confidence, it has to be said. But they allowed me to get up and running and get something actually to execute. So that was okay, but then, you know, as we've been saying, one of the great things about Spark is the amount of momentum behind it and the way that's causing lots of other technologies to get behind Spark. And recently, we've seen that both Google with their Dataproc service and for us, importantly, EMR from Amazon, their Elastic MapReduce service, now officially supports Spark, which is brilliant, except for the fact that whereas I'd been dealing with standalone mode with the Spark EC2 scripts, once we were trying to do stuff on EMR, that meant we were dealing with Yarn. And I don't doubt that Yarn has many good qualities, but as somebody coming to it without any experience with it, it was yet another new technology for us to try and get a hang of and trying to get our heads down and use effectively. And one thing in particular threw us off base for quite a long time, and that's the wildly different defaults you get between standalone mode and running on Yarn. In standalone mode, default when you submit a job is that it will consume all the resources available on the cluster. And for a number of the jobs that we were trying to do, that's exactly what we wanted. When we came to run stuff on Yarn, it was a while before we actually got through and read the documentation properly and realized that, yes, the defaults for Yarn are indeed to run on one core of 2 executors. Now, that doesn't really strike me as something which is going to make very good utilization of any kind of cluster that I've ever seen. So, you know, I can understand that coming from the MapReduce world where you've got lots of small jobs going on, but where we're often talking about one big job in our use of Spark, this wasn't what we wanted at all. So rapidly getting on to actually using these parameters to tell Yarn how to use these things effectively was something we had to get hold of very quickly. We haven't gone down and managed to get working the dynamic resource allocation that was being talked about in the last talk. That's definitely something we're looking into in the longer term, but again, the sort of overhead of getting that up and working is non-trivial for a team of our size. So, you know, in some ways, I'm making it sound like, compared to certainly some of the other talks, that we haven't really got on very well with Spark. But actually, you know, it has worked well for us in some areas. And so I'd like to tell you a bit about where we have seen it come out and provide an effective tool for us. And the first of those is this fact of providing ML where it's relatively simple to get up and working, have algorithms which have already been implemented and been tested by a number of people, and get something working without a huge background in the field. So for that prototype that I was building, this was a great help to us. Now actually, turns out where we're going with that at the moment, we're actually looking to use prediction.io, which is giving us a slightly sort of higher abstraction still on top of doing recommendations. But like, we already now have the confidence of the algorithms underneath that from having tried them with Spark. So that's one thing which we found that it really worked nicely for us. Another area where we found Spark to be really effective is doing bulk transformations of data. So again, one of the things we've been looking at, again, is looking at which different file formats are the most effective for querying against. And as long as you've got your data in some form, which you can read into a data frame, actually then persisting it in another in order to do some analysis of becomes completely trivial these days with the data frame API. It's basically just load it and save it in a different format and you're done. It's a really simple, effective way of doing that. And then introducing some transformation into that is, again, pretty simple and efficiently done. And then the third area where we found that it's worked really nicely for us is ad hoc querying. So again, particularly now that we have the data frames API coming in, it provides a way to really blend the best of the relational model of querying data with being able to actually, provide your own functions in a very natural manner into the system rather than having to move into the world of sort of UDFs and so on, and mix the functional paradigm with the relational one. And that's something which I think is a really nice benefit of using Spark. And similarly, having the ability to query across lots of different backends and lots of different file formats, that's something that we really value. We have, in the past, tried to do things building a kind of data warehouse with the big ETL, and we have really felt the pain of trying to do that kind of ETL into one single format and source of truth from many different sources of data, which have, frankly, quite widely varying quality and quite widely varying importance and value to us. So being able to have this idea of the kind of data lake or just-in-time warehouse where you can actually just bring all of that data in and then still have a reasonable approach for doing querying across it when you have a query that just needs to pull in what it needs, when it needs it, and address the problems at that point is something which we think is really valuable. So I guess what I'm really trying to say to you is Spark a golden hammer for all of our big data woes? Well, no, not really. But then we weren't expecting it to be. There is no perfect solution which is magically going to solve all our problems. But is it proving to be a useful part of our toolkit, which we can use alongside various other things, such as Elasticsearch? Yes, absolutely. It's definitely being something which we think is going to be an important part of how we deal with data going forwards. Thanks very much for all your time, and I'm happy to take any questions.
Hi. So very good talk. I'm very glad that you decided to go for Scala and do things in a proper engineering way. So my question is, I see a lot of engineering life cycle in your probably what you built. Have you followed any agile methodologies in that? And how different was applying agile for building applications that they're not really like software development, where you know already what the requirements are? How did you manage to actually get the analytical part and the development into your life cycle and the development cycle?
So, I mean, we definitely come from, in terms of sort of methodology, we definitely, our history as a company, sort of 10 years ago, we were very into XP, and we've gone through a whole sort of range of different sort of broadly agile methodologies. In the way our team in particular works these days, our methodology is as minimal as possible with absolutely everything, and trying to just engage directly with our stakeholders, minimize the time we take to get feedback on things, get things in front of users as quickly as possible, and try and concentrate on minimizing the feedback cycle and use that as a driver for almost everything else. And so in some ways, getting to that point helps with the idea of getting to the point where we can also do things like mixing in, building queries for people, and analyzing the data into that same kind of flow, because we want both to have that quick feedback and turnaround and getting direct interaction with the user into both elements, if that makes sense.
Thank you.
Hi, thanks for the talk. Now that you have Spark up and running, I'm wondering what exactly is it that you're achieving with it? Are you doing content analytics or user analytics or article recommendations, or what exactly is it that you do?
So if I understood the question correctly, the question is, what is it we're really trying to achieve overall? So there are a couple of different threads. The biggest, the main two areas we're using it for at the moment are for doing the kind of ad hoc querying around the data to answer the kind of questions we can't answer through Elasticsearch around our content and how it's being used by our users, how it's being consumed by our readers. So to take an example that I've been working on recently, one of the things that you can do in the dashboard is see for a piece of content what proportion of the people reading that were people who visited our site one day in the last week versus all 7 days in the last week, for instance. And a question that came up about that was, well, actually, we don't just operate out of London, we operate out of Australia and New York and other places around the world. If we localize the time zone rather than just using London as the time zone to specify that day, does that significantly impact how those groups break down? And that's the kind of thing that we can use Spark for there. More broadly, and this is something which we're only just starting to really do, is actually to mix in a much larger range of data sources and ask the sort of business intelligence or product questions around what we should be doing by aggregating all of those different data sources together. So things like data from our ad serving platform and mixing that into the system and trying to understand how content and advertising and how that's consumed interacts. So that's at a much more nascent stage. So it's kind of, that's where we think there is a good use for Spark in some elements of that, but it's not there yet.
Let's give Phil a big hand.